Today's lesson is on topic 4 review. Leon has a container filled with 450 grams of tea leaves. Each morning, he uses 3 grams to make a cup of tea. Write an expression to represent the amount of tea leaves remaining after X days. Take a second to copy down the question. The first thing I see and notice is that it tells me to write an expression. An expression, as remember, has no equal sign, so we should not be writing out any equal sign. It also says after X days. Since it says after X days, I know what my variable stands for, so I do not have to label my variable. He starts with 450 grams, and then he uses 3 grams to make a cup of tea. So if he starts with the 450, and then if he uses them, we're going to be subtracting them. So we're going to have minus 3 per day, so it would have to be 3 times X to represent the amount that he uses each day. And since we do not know the number of days, we're going to keep that as X. So that would be my expression, 450 minus 3X. The second question, write an equivalent expression to the following. 0.5 parentheses negative 1.4 m plus 0.4. Take a second to copy down the question. When I have to write an equivalent expression, that means I'm writing the same expression but just in a different form. In this case, I can get rid of the parentheses using my distributive property. So I can distribute the 0.5 to everything inside of the parentheses. When I distribute, I multiply. So 0.5 times negative 1.4 gives me negative 0.7 m. 0.5 times a positive 0.4 is equal to a positive 0.2. So this is an equivalent expression. Negative 0.7 m plus 0.2. These two expressions are equivalent or equal to each other. Simplify the following expression. 8.9 minus 1.4x minus 6.5x plus 3.4. Take a second to copy down the question. When a problem says to simplify, that means I need to combine all my like terms. So I look at my problem for like terms. Like terms either have the same variable or no variable at all. The first term I come to is the 8.9. The 8.9 has no variables, so I look to see what else in the problem has no variables. I notice that the other term that has no variables is this positive 3.4. So I can add them up. 8.9 plus 3.4 is equal to 12.3. Now I can cross those out since I used them to keep myself more organized. The next term I come to is negative 1.4x, and that like term to that is negative 6.5x. Make sure you take the sign with them as well. Negative 1.4x minus 6.5x gives me a negative 7.9x. So I used and combined those two like terms. Now I look at my final answer. I notice there are no more like terms, so that can be my final answer. If we want to get in the practice of writing this in what we call standard form, the variable should come first. So I can rewrite this as negative 7.9x. That term would come first because that has the variable, plus the 12.3. Both answers are correct, but the second answer, the variable coming first, that's how we want to start writing our final answer. Factor the following expression: negative 5g plus 15h minus 25. Take a second to copy down the question. When the problem says to factor, that means I need to turn my expression into some term being multiplied by other terms inside parentheses. In order to do that, I need to find my GCF of every single term. I look at my numbers first. I have 5, 15, and 25. The GCF of those numbers is 5. So my GCF is going to have a 5. Then I look at my variables. I have G, I have H, and I have no variables, so there's nothing common there. Since my first term is negative, my GCF is also going to be negative. So my GCF is negative 5. That means I'm going to have my negative 5 outside the parentheses, and now I have to determine the terms inside my parentheses. In order to find that, I'm going to divide every term by my GCF, which is negative 5. Negative 5 divided by negative 5 is 1, and the G just comes down. Positive 15 divided by negative 5 is negative 3, and the H just comes down. Negative 25 divided by negative 5 is a positive 5. So this would be my factored expression. Now if I wanted to check to make sure that my answer is correct, I can distribute my GCF into the parentheses and make sure my new expression is the same as my original expression. Negative 5 times 1g is negative 5g. Negative 5 times negative 3h is a positive 15h. Negative 5 times a positive 5 is negative 25. And since this expression is the same as my original expression, I know my work is correct. That second part in red was just a check. You do not have to do that every time. That's just to make sure you're doing it correctly. The next problem. Lauren grew pea plants. Pam grew 5 fewer than 3 times the number Lauren grew. Ken grew 6 more than 4 times the number that Lauren grew. Write an expression to represent the total number of plants that Lauren, Pam, and Ken grew. Simplify the expression. Take a second to copy down the problem. In order to make this easier, I'm going to list out all 3 people and write an expression for each person. Lauren, we knew, grew pea plants. The next person is Pam. Pam grew 5 fewer than 3 times the number that Lauren grew. Whenever we see 5 fewer or 5 less than, we're going to put that at the end. And since it's fewer, it's going to be minus 5. Now I need to do 3 times the number that Lauren grew. Since Lauren grew P, 3 times that would be 3P. And the next person is Ken. When I look at Ken, it says Ken grew 6 more than 5 times the number Lauren grew. Same thing, if it says 5 fewer, 6 more than, I'm going to put that at the end. but this time it's going to be a plus 6 because it's more than. 4 times the number Lauren grew. Lauren still grew p, so 4 times that number is 4p. Now the problem wants us to find the total. If I want the total, I'm going to add them all up. So I'm going to have p for Lauren plus Pam's 3p minus 5 plus Ken's 4p plus 6. And now I'm going to combine my like terms to simplify. I have a p, a plus 3p, and plus 4p. When I combine all of those, I end up with 8p. And I can cross those out to show that I used them. My next like terms are this minus 5 and plus 6. Negative 5 plus 6 is plus 1. So the total amount of plants that Lauren, Pam, and Ken grew is 8p plus 1. And the last problem. Subtract 2y plus 14.6m plus 3.8 from 34.8m plus 15.6 plus 2y. Take a second to copy down the question. Now the key part to this problem is making sure we put the two expressions in the correct order. We are subtracting this 2y plus 14.6m plus 3.8 from this 34.8m plus 15.6 plus 2y. That means we are starting with the 34.8m plus 15.6 plus 2y. And I'm going to keep that in parentheses. That is what I'm starting with. And then I am subtracting from that the 2y plus 14.6m plus 3.8. And I am also putting that in parentheses. That part is very important to keep both terms, both expressions in parentheses. Now there's an imaginary 1 in front of this parentheses that I can distribute to every term inside my parentheses. When I distribute, I'm left with 34.8m plus 15.6 plus 2y. Now this minus sign, there's also another imaginary 1 here. So now I'm going to distribute this negative 1. When I distribute this negative 1 times 2y is negative 2y. Negative 1 times positive 14.6m is negative 14.6m. Negative 1 times positive 3.8 is negative 3.8. Now that I got rid of my parentheses, I can combine my like terms and simplify. I'm just going to go term by term. The first term I see is 34.8m. I look to see which other term has an m, and I find this negative 14.6m. 34.8m minus 14.6m leaves me with 20.2m. And I can cancel out both of those terms since I used them. The next term I come to is this positive 15.6. And the other like term to that is negative 3.8. 15.6 minus 3.8 is equal to a positive 11.8. And I use both those terms, so I will cancel them out. The next term I come to is this positive 2y. The like term to that is this negative 2y. When I look at both of those, positive 2y minus 2y is 0, so I can just cancel those out. So this is my final simplified expression. 20.2m plus 11.8.